very hard.
No, it's not. It's never very hard. Okay, lesson 44. These are things you already know because it's fractions, but now it's fractions with variables. So, what do you think you do? I'm going to give you information and you tell me if you know how to do this or you think you know. Whatever applies to numbers applies to variables as well. What's the first thing you have to check when you add fractions? Same denominator. Do they have the same denominator?
Yes.
So can you add them just like that?
Yes.
So I'm going to put the same denominator in the bottom.
Subtract.
And I've got 4 minus 6ax. Is there anything you can do in the top?
No.
No. Why can't you subtract minus 6ax from 4?
Because they don't have the same variables.
They don't have the same variables, they don't have the same last name. It's lemons and pineapples, right? You can't do that. Okay, so this one, obviously an easy one. Let's do something that doesn't have.
That's the answer.
Yes, that's the answer. Ah, but it gets harder.
No.
How about we have this? Plus 7.
Leave it easy.
Yes, and there's a catch to this one. Let's see if you can catch it. Minus 3x minus 2. Okay. First thing you check, do you have the same denominator?
Yes.
Yes, okay.
All in the numerator is adding and in the other side is subtracting.
This one we copy because it's adding and there's nothing in front of
And
it.
the other one is adding because minus and minus equals plus.
But there's a minus here. So when you pass it to here, please put parentheses so that the minus affects everyone. And that way you don't make a mistake. Does everybody see why I added parentheses?
Yes.
Because the minus affects everyone, right? So that's 5x plus 7 minus 3x plus 2.
Yeah.
Is there anything you can simplify in the numerator?
Yeah.
What can you simplify?
5.
5x minus 3x?
Plus 7
That would be 2x, right?
Yes.
And 7 plus 2?
9 plus 9.
Plus 9.
Over 5.
5a squared x. And that's your answer because you can't simplify more, right?
Can you
So let's do one where you don't have the same denominator.
pick up the x or no?
Which x? This one? Ah, good question. Can I take this x off with this one?
Yes. No.
Yes and no. The reason why it's a yes and no is because you have a plus sign at the top. If you have a plus sign up, if you didn't have it, you would be able to. But you have it. So, what this really means is that you have 2x over 5a squared x plus 9 over 5a squared x, correct? So you can only, if you decide to take it off, you have to separate it, and then you can simplify. But then you're going to have
They're not the same denominator.
not the same denominator. Either one of these is correct. I don't require you to go all the way down here. You can leave it here, okay, with the same denominator. Is that clear? Mm-hmm. Is it clear why this x cannot be canceled out with this one?
Yes.
Everyone clear? Okay. So let me do one where you have different denominators.
Uh-oh.
Uh-oh. Remember that yesterday we saw least common multiple with variables? This is where you're going to use it. So, let's say let's start out with something simple. 3/4 plus 2b. Ew. Different denominators. So what do? What's this? What would be the least common multiple between 4 and b?
4b.
Very good. 4b, because it's got to include everyone, right? What did I do to the 4 to get a 4b?
Multiply
Multiply by what?
by the
What did I multiply 4 by to get 4b?
1.
B.
Oh.
You multiplied it by b. So what you do in the bottom, you do in the top, because that way it's a 1, and that's how much in the top?
3b.
3b. Plus this, what did you multiply the b by to get 4b? 4. So what you do to the bottom, you do to the top, and that is an 8. 3, and this is your answer. Now that's a really easy one. That's a very simple one. So let's do a harder one, shall we? Questions on this one?
No.
No? Really simple, right? How about over x plus x over b plus a over c. And I'm only going to do this one and one more, and then I'm going to let you go in peace. What's the common denominator?
XBC.
Does everybody see why? Yeah? XBC. What's this one missing?
BC.
The BC. So it would be 5 BC. This one, what's the B missing to go to X and C? So that means x squared, because you already had an x, and x times x is x squared, xc plus
A square B.
why a squared.
Biggest C. Big.
What is the c missing to be xbc?
XB.
xb times a?
AX.
axb or abx, it doesn't matter. The order doesn't matter. Why doesn't the order matter again?
Because it's commutative.
Because the commutative property of multiplication
Many
allows you to
people-
do what?
Many people
To
do
multiply
it.
it.
The book does it in alphabetical order, right?
That because the standard is to do it in alphabetical order. It's the standard. But if you don't leave it in alphabetical order, then it's fine. In fact, before alphabetical order comes the square. So in the end,
What? So
the exponent takes precedence over alphabetical order. Okay, but it doesn't matter. That's fine.
Like, it would be like supposed to be squared AB or something.
Or it could be cx squared. It doesn't matter. Doesn't matter in the end. The point is, did you understand how to do this? And now, let me do one last one. Just to make sure that you understand what happens when you've got something like this. Okay. What's the common denominator there? C.
It's 12C to the power of 4.
Does everybody agree, or does someone think it's something different?
No.
Everybody agrees?
Yes.
Remember yesterday with the least common multiple, we took the highest exponent because that includes everyone, right? So, same thing. What's this one missing? What's
C.
just the C?
Four. 2 C's. C squared.
4
C,
C's.
it's missing a C squared. And what else is it missing?
12.
The 12. Remember that the number goes first. So it's missing the 12 and the C squared. What's this one missing? The 4C cubed. What did I do to 4C cubed to get to 12C to the 4?
3C.
So the 12C. 12C.
9 over 9C.
So plus 9C. And what did I do to 3C to the 4 to get 12C to the 4?
Times 4.
Times 4.
Okay. Times 4? Is that it?
Yeah.
Yeah.
So what do I put here?
Times 4.
4S.
Right.
Is there anything I can simplify there?
No.
So that's how I leave it. This is my answer. Questions? Pretty simple, right? The same thing you do to numbers, you do to fractions with variables.